Let's start. Who's currently using objective quality metrics with their videos? Anybody? Okay, so I don't mean to interrupt you two, but okay, good. So what we're going to discuss this morning is fine-tuning your adaptive groups with objective quality metrics. And by way of background, I used to look at my videos the old-fashioned way. You'd encode two videos and you'd put them side by side and you'd play them side by side, and then you'd make some conclusion about quality. And we'll see some examples of that. And I guess it was 2 summers ago I had a consulting project that involved, it was like comparing 200 and something files with 4 different technologies. And I quickly realized that there was no freaking way I could do that side by side, even if I put it in a nice Premiere timeline. So I bought the Moscow University video quality measurement tool, and I kind of fell in love with objective quality metrics, and it's been the basis for a lot of the reviews that I do, a lot of the consulting projects that I do, and that's what we're going to cover today. So, wanted to start with a couple of quotes. I mean, it's really kind of funny because there are so many people who have so many strong opinions about video compression that are totally not based on any kind of fact at all. They're really just opinions. And when you get objective quality metrics, I mean, they're not 100% perfect. They don't overrule subjective benchmarks, but they are valid. And they do provide a lot of really good information. And I think instead of having an opinion, you should try to be informed instead of just opinionated. So I think, in a nutshell, that's why I like objective quality metrics. There's a tremendous amount of opinion about what you should do and what you shouldn't do, and how much difference stuff makes. But at the end of the day, there's no reason to have an opinion about it. You can very quickly and easily test it and draw a mathematical-based conclusion. So spend a little bit of time on what objective quality metrics are, the tools that I use, and then how I apply that to configure my X.264 encodes. Then we'll look at measuring adaptive groups, choosing the optimal resolution for your adaptive groups, and then question and answer. So that's kind of it's a short little 45-minute session, a lot of slides to get through. So what are objective quality metrics? Basically, it's a mathematical formula that's designed to predict how human eyes will view a video, right? So what we're trying to do is subjective tests are expensive to do, they're time-consuming, and it's very hard to tell little differences between the clips that you're encoding. And what objective quality metrics like the peak signal-to-noise ratio, structure similarity, video quality metric, or simplice, what they try and do is predict how humans will subjectively evaluate your videos. And some do a more or less better job of it. Who here saw Netflix's big blog post about per title optimization? So what the video quality metric that Netflix used was the PSNR rating. So they built their whole system based around PSNR. So I didn't, I kind of like the VQM metric, the third on the line, and the SSIM plus metric. But as soon as Netflix said, hey, we find this valid, it gave it a lot of weight to me. So a lot of the stuff we're talking about is stuff that companies like Netflix and YouTube and other really high volume producers use in their day-to-day production. So this is this is me before, and I thought I was pretty sophisticated because I would encode my videos, I'd put them on a Premiere Pro timeline, I'd have the alternatives, and so I could look frame by frame and do subjective comparisons. But it's very time consuming and it's very inexact. And I went from this to this. And this is really kind of, from my perspective, I'm kind of a compression geek and have been for too many years, but you look at something like this, and this is the consulting project that I kind of referred to at the start. This is just one of, I think, probably 30 or 40 charts I had to do. So what I was able to do in this chart was use the VQM, lower scores are better, 16 different clips, 3 different technologies, and then using pretty simple programming features in, I guess, Google Sheets, I was able to say, okay, which one of these is the highest? That's in green. Which one of these is the lowest? That's caution, orange. When is the difference over 5%? So which clips should I look at? And I was able to get all this information in a pretty automated way. So, I went from looking at videos side by side to really objective facts. And if you're doing this, if you're doing this for yourself, that's one thing. If you're doing it for a boss, or if you're doing it for a consulting client, and you show them this kind of stuff, then you just get tremendous credibility. So, and you get a tremendous amount of useful information. You get instantly visible information you can access very easily, and it's very, very credible. So basically, you get more data, better data, and as we'll see, basically you just input your test files, and the program delivers a score for you. And my take is, you can never trust 100% the results of objective quality metrics. You've always got to do some level of checking, real-time playback to verify what the numbers show, because they're not 100% reliable. But this is an example where I was able to grab a frame from the movie Zoolander that which is better, CBR or VBR? Well, CBR, that frame in particular, is one of the frames that was really reduced in quality because CBR ran out of wiggle room, right? So this is an example of when you have a very transient quality deficit, and we'll see how the video quality measurement tool from University of Moscow helps us identify these types of frames. But if the client says, I want to use VBR because it's better quality, I can say you should use VBR. If they say I want to use CBR because it's more reliable and easier to stream, I can say, well, this is the potential problem that you may run into. Tools that I use, the Moscow University Video Quality Measurement Tool, that's about a $1,000 tool, and then the SimWave Video Quality of Experience tool, and that's about a $2,400 tool. And the workflow for this tool, I like to make these camera guys work. You basically have the ability to load one source file and two test files. So if you're comparing VBR and CBR, or one data rate versus another data rate, you can put the two files in, choose your metric here. It can be PSNR, SSIM, SSIM plus. It's got 20 or 30 different metrics you can use. Press process, and then it starts to wind. And then this is the results visualization screen. And what you're seeing here is, this is the score for the entire file. This down here is this region here. So it's kind of a close-up of the entire file. This is the first process file. So this is the VQM rating. So this is the first file. And with VQM, lower scores are better. This is the first file. This is the second file. So you can see there's pretty significant gaps in overall quality just by looking at this. And what you can do here is look at this to slide through the frames. So you can go from this particular test file has about 1,400 frames in it, or I think it's 2,800. That's at this location. So you can drag this to any frame, and then click there to show the frames, and this is what you have in front of you. So you've got, this is the frame visualization screen, and here's the original file, first process, second process, and you can toggle through with 1, 2, 3 on your keyboard, and you can see exactly what each frame looks like as compared to the original. And if we have time at the end, I'll show you how that works on my computer here. And then you can also zoom in if you find that useful. So what do I like about this tool? It's cheap. It's got multiple algorithms, and my review of the tool, which was for streaming media, I guess it was probably January of 2015. You can see the bit.ly. You can see the bit.ly link there. The negatives, you can only compare files of like resolution. So when I'm comparing a 720p encoded file from a 1080p source, and I want to compare it back to the 1080p source, I've got to convert the 720p file to a 1080p YUV file. And that's time-consuming and disk-consuming. And then the thing that's a little bit negative is the scores don't directly correlate to subjective perception. So I know that what Netflix said is that any score above a 45 PSNR value is indistinguishable to the viewer. So what they, in their work, they said, we're going to make sure we never get a score above 45 because we're just throwing extra bandwidth that's wasteful, because nobody can tell the difference between 45 and 46. So I know that. Anything below 30, 35 to 30 is going to start to look a little bit degraded. But there's no direct correlation. That's kind of stuff that you pick up. And as we'll see in a second, the the simplice tool, they rate based upon what they predict will be the subjective evaluations. And then the last thing about the Moscow University tool is they don't correlate the scores with any playback platform. So they give you one score, and the negative about that is that score, a score that's accurate for an iPhone isn't going to be accurate for an 80-inch TV, right? A file that may look great on an iPhone is going to look terrible on an 80-inch TV. So that tool just gives you one score, and then you have to kind of figure out how it's going to apply to the different platforms that you're playing on. So this is the SQM SimWave Quality of Experience Monitor, and it's based upon the simplice algorithms. SSIM is one of the most respected. It won an Emmy a few years ago for, from Hollywood for its use there in terms of quality control. And this is the next generation SSIM, but built by the same people who originally came up with SSIM. And what they do, as I talked about, they produce a rating that they think will match the viewer's subjective evaluation. So 80 to 100 is excellent, 60 to 80 is good, 40 to 80 is fair. So you can use this tool, and if you trust these numbers, then you can say, okay, I just want to make sure all my clips are between 80 and 85. Because anything above that really doesn't matter because it's all excellent, but if it's below that, we're going to drop into the different categories. The other thing that this tool does a nice job with is predicts ratings on different devices. So you can say, tell me how this file looks like on, tell me how this file looks on an iPhone, tell me how it looks like on a 4K TV. And if you're distributing for multiple platforms, which most of us are, that's pretty valuable information. Both of these tools have command lines, and my review of this tool is at that bit.ly URL. This presentation will be on my website. My website is streaminglearningcenter.com, and I will post this to my website right after the class. Okay, so if you want to just write down streaminglearningcenter.com, and you can get all this stuff, and I'll sit up here and do it. I'll delay my lunch because I felt bad about not doing it before I got here. Okay, and this is the SQM workflow. It's kind of the same thing we looked at with Moscow University, except it's only one file. So this is the test video file. This is the reference file. Load this, load that. And then here's where you choose the different viewing platforms that you want to evaluate. So they have everything from 4K TVs to old iPhones. I think there's like 30-something different platforms you can evaluate, which is good because if I'm testing an encoding ladder that's targeted towards mobile, I can say, show me iPhones and tablets, and that's all I evaluate. If I'm looking at OTT for home viewing, I can look at TVs. If I'm looking at computers, I can look at monitors and notebooks. And then here's the visualization. This is the original file. That's the compressed file. This tells you the differences between this file and that file. And if you'd like, you can use a toggle switch to toggle this to the test file. So if you want to see how the tested file looks compared to the original, you can do that. If you want to see the information that identifies how much differences there are, you can look at that. Here are the ratings for the various devices that I had selected for this evaluation. The results are presented in a CSV file. So you see the simplice scores, the first column, and that's kind of an overall score. And then we see the scores for the Sony X9, which is a 4K TV, the Samsung, it's another, and then a Lenovo monitor. So we see that the 4K TV in expert mode assumes that you've got a person 2 feet away looking at the pixels, and that's the score that they predict. And then they've also got some graphical comparison tools. They've got this, where you can look at the comparative flow lines, like we saw with the Moscow University tool, and you can also look at the different files in a video window. So this is a separate tool. It's not integrated into the main tool. What do I like about simplice? Kind of talked about this before. It uses a very proprietary, but I think very high quality algorithm. The scores correlate with viewer perceptions. It tells you about multiple devices. It can handle multiple resolutions. So if I throw a 320 by 240 file, I can compare it to the 1080p file that I encoded it from without converting to YUV. And if you're looking at hundreds of files, that's a huge difference. It's more expensive. It does have limited algorithms. Basically, it's simplice, sim, and PSNR. And the visualization tool isn't as accessible. The Moscow University tool, if you want to compare two files, man, that's just a great tool. I mean, it's right there in front of you in the main tool, and it's really easy to work with. So here's how I use these tools and some of the common things that we face every day when we're creating our presets and encoding our files. So all these tests were performed with Sorensen Squeeze, and most of them are 720p at 2 megabits per second. Or 720p at 2.5 megabits per second for 30 frames per second. And then we'll look at the different presets and look at the different parameters through these tests. So the first test that I wanted to run is which presets. Everybody, who here uses X.264? And pretty much a lot of people. It's a very, very high quality, very popular codec. It comes with it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 presets you can use. So which one do you want to use, right? Medium is the default in most applications. What I wanted to do is figure out, is that the right, what's the best preset if you're encoding your different files. And I've used, every file is different. So I'm writing a new book that's keeps getting delayed. But I'm looking at one movie file, Tears of Steel. I'm looking at 2 animations, Sintel and Big Buck Bunny. 2 general purpose files, a concert file that I shot. 1 talking head video, because we have a lot of talking head videos. Then a screen cam, which is Camtasia based, and then a tutorial, which is just PowerPoint and video. So I wanted to see how all these files reacted to the different presets. And so this is a VQM score. Lower scores are better. And what I found was, so here's the average encoding time. Here's the average VQM quality. And the average SQM quality is there. So what I found that, you've got 100% quality down here, actually at the placebo preset. But you've got 98% of the quality in the super fast preset. So what does that tell you? That tells you if you're computer constrained, if you have limited resources, you're going to have to buy a new computer to encode your files. The first thing you can do is drop from medium to super fast, because you're not going to see any real quality difference. And then if you graph this, graphing I think is always good, because it kind of puts a lot of data in front of you. But so the blue is the encoding time. We see the encoding time is really, really identical up to medium, and then we start to see it poking along, getting a little bit higher, and then at very slow, it's still not too bad, but at placebo, it just goes crazy. So you could take like the opposite tack and say, well, what's the most quality I can get with reasonable encoding time, and that's here. Or you can say, what's the most quality I can get with the shortest encoding time, that's here. So when I go to a client, I say, okay, these are the choices you want to make. And if, medium, it's not a bad, it does what it said it does. It kind of puts it in the middle in both cases. But if you're running short on encoding time or encoding speed, then you want to back off to maybe the super fast. If you're not encoding constrained at all, you might want to go to very fast and get more of that quality. And then X.264 tuning mechanisms. So there's tuning mechanisms for animation, for grain, for film. Do those help or not? I just finished a project for a client where I looked at 10 different animated files, and the animation tuning improved the quality in all 10 files. So that's really not something you could see side by side, but it was like a 2.5 to 3% improvement, which is pretty huge in the encoding space. And the client, I think, is going to go forward using animation tuning for all animated codecs. And then how about the film grain or film and grain? Red means bad, green means good. Basically, the tuning effect dropped the quality as compared to the regular in 2 of 3 cases. And one of the quality drops was pretty significant. So from my perspective, what I advised the client to do was use animation tuning, not to use film, not to use grain. And then this is my favorite one. We talked about this in my session a couple days ago. It's how much difference does keyframe interval make? A lot of people think it's a very, very huge difference. In fact, it can be pretty significant. But if you've got a client who says we need a keyframe interval of 1, that's what we use all the time, you can show them a chart like this and they say, well, it's always the worst case. On the other hand, if you look at the difference between 2 seconds and 3 seconds and 20 seconds, it's not that great. So if you're trying to, so my rule of thumb for general purpose streaming is between 5 and 10 seconds if it's single file, and either 2 or 3 for adaptive bit rate. And you can see that it is better to go longer if you've got a single file not adaptive. On the other hand, if you're doing adaptive bit rate streaming, you need to be shorter for different reasons. And then VBR, CBR, again, 2-pass CBR is always the worst quality. And I'm sorry, CBR 1-pass is always the worst quality in this series of tests. And 200% VBR is probably the best overall quality. So if you have a client that says, I'm really concerned about deliverability, I want to use CBR, you can say, well, not a bad decision from a deliverability perspective, but you are leaving some quality on the table. And the numbers do get pretty significant on the extreme right, including with the screen cam. That was the most confusing one to me. I still don't really understand it. You got a 45% difference between the highest quality and the lowest quality, which is very, very significant. Okay, so this is the results visualization screen. That we saw this from. We saw this a few minutes ago. This is CBR versus VBR. This is another example where you see definite quality differences in the CBR as compared to the VBR. And this is a spike. This is an example where the results visualization makes it very easy to see the differences. CBR versus VBR is poking along, doing very well here. But on some particular sequences, you're going to see a huge difference. And that's what you care about, because that's the major quality deficit that your clients are going to look at and complain about. And then here again, this is the clearly degraded frame as compared to the VBR frame over there. The other thing that I like to look at, we care about quality, but we also care about deliverability. And this is a tool called Telestream Switch. And this is the CBR file, and this is the VBR file. So the VBR file, the target looks to be about 700 kilobits per second. It's going all the way up to, I think that's like 3.8 megabits per second. So which file would you rather deliver to a mobile device? This file or this file? And again, if this gives you information to present good information to your bosses or your clients and say, we don't want to use CBR because the quality deficits. Well, if you show them this, it's like, if you've got somebody on a fringe connection, this file is going to be much easier to deliver than this file. Okay, so building your encoding ladder. These are kind of the steps that I take. Step 1, I choose the lowest rate for mobile. I focus on mobile first. And people are just, clients can say, we want to do 300 kilobits per second or 200 kilobits per second. They're going to have an opinion about that. They're going to have an opinion about the highest supported data rate. Usually that's a cost decision. How much do you want to spend at the high end? And then you're going to choose a data rate around 3 megabits per second. You just want one around that neighborhood because that's kind of the highest sustainable rate according to the output or the statistics that Netflix distributes. And then you're going to want to fill in the blanks between using steps between 150 to 200%. So you might see a ladder started at 200 kilobits per second. You might see at 4,600 kilobits per second at the high end. That's what the customer says, the most they can spend for their stream. You want your 3 megabit per second data rate because that's the one, the highest data rate most people can sustain. And then you just fill in the gaps. You go down 50% or some measure like that, and you fill in the gaps that way. So it's a nice logical. And this is not set in stone. If you ask 10 people what the ideal ladder was, they'd show you 10 different answers. But in terms of, the client has a fixed opinion about what they want to do at the low end. They have a fixed opinion at the high end. The 3 megabit per second number is an important one because of what Netflix says. And then the rest, you just don't want to be too far. You don't want to be too close. You don't want to strand somebody at a low data rate because there's no one that they can access that's just a little bit higher. But you don't want to have too many in there so that they're constantly switching from one to the other. And then what you do is, so we have this information. The next question is, the next question is, what resolutions are you going to use at each data rate? And so here's where, so basically you just start encoding files at different resolutions and coming up with different PSNR ratings. Okay, and this in essence is kind of what Netflix did. They used a different way of getting here, but they basically encoded files at 1080p, 720p, 540p, 360p, and these are all the typical resolutions you want to encode at. So this is the raw numbers, and then again, by using a tool in your spreadsheet, you have a column over here that has what's the maximum between this, and then which value matches the maximum. We'll turn that one green. So we know immediately at which data rate, which is the highest quality alternative, and then we turn it into a chart where we have the ability to very quickly say, okay, what's the best stream at 3 megabits per second? Well, it's the 1080p stream. What's the best stream at 1500 kilobits per second? Well, it's the red stream. It's the 720p stream. So at any point, you can see the highest resolution from a quality perspective. You can also see which sizes are never the highest quality. So this is the 180p stream, and this chart convinced the client to just drop the 180p stream because it's never the best quality according to these numbers. Okay? And the 270p stream doesn't have long to live either. It's really not providing a lot of value at any data rate. So at any point, you can see what the highest quality resolution is. You can see which sizes are never going to catch up. And you can also gauge the slope of the quality curve. So a lot of questions you get is, well, I said I wanted 4600, or I said I wanted 4 megabits per second. How much, should I go higher? Well, if you can show them this curve, you can say, okay, well, if you go from here to here, you're really not gaining that much. You gain a whole lot when you go from here to here. But if going out towards that end, you don't gain a lot of quality. So all this stuff is really, really simple once you have the data. And so this is an H.264 curve. What's this going to look like with HEVC? What do we think is going to be different? Pardon? Always use higher res. Why? And this is really kind of interesting because you want to tell her? Go ahead. No, you go ahead. The 180p file has a lot. If we're an OTT house, we're playing this full screen. There's a lot of built-in scaling artifacts in this file. And no matter which compression technology you use, if you send out a YUV file, when you scale this to full screen, it would have a lot of aliasing artifacts because you subsampled it all the way down here, you're subsampling it back up. With these files, you have compression artifacts. They're larger resolution, but because they're larger resolution, you have less bits per pixel, so you have more compression artifacts. As your compression algorithms get stronger, you have less and less compression artifacts in the higher resolution streams, which makes the lower resolution streams less valuable. That's what you're going to say, right? So, anyway, this is the kind of stuff that you don't really, you may know it intuitively, but it jumps out at you when you actually plot the numbers and look at the graphs. And then here's, basically at any particular resolution for HEVC, the green one, I guess 360p, 270p, and 180p are never the highest quality alternative. And we have numbers that, they're not in this presentation, but the numbers back that up as well. And you can also look at the slope. What's the additional value of going from 3500 to 4500? Well, here's our 45 number. The Netflix 45 go beyond this, and you're essentially wasting money. So, going from 35 to beyond 45 is a waste of money with this particular clip, with this particular compression algorithm. So, how much is this going to change by codec? It's going to totally change by codec. How much is this going to change by codec implementation? It's going to totally change for each codec implementation. So, if you're using X.264 as compared to, the main concept codec, or you're using X.265 as compared to any of the other alternatives out there, these numbers will look totally different. And they'll also look, as we'll see in a second, they'll look totally different for different types of content. So what I showed here was basically general purpose movie content. Okay, so the next question you address a lot is, do you need the higher quality stream? So this is an encoding letter that's close to what I received from a client, but not exactly. I kind of exaggerated a bit to make a point. But but you see a lot of people with multiple 720 or multiple 1080p ladders, and you can justify a switch from 5 to 7.5, and that's a big enough jump. This one is probably too close for comfort to either one of these. But then you look at the numbers, and the SQM score. Again, this is a subjective evaluation that's supposed to relate to how the viewer will judge this. This file is 95.66, which is excellent. This file is 95.91. So in this case, you really can consider dropping both of the higher end files, because you're really not going to see that much of a difference between the 5 megabit per second file and the 7.5 megabit per second file. And that's what the numbers tell you. So, and if you want to look at it even more closely, you can plot it in the results visualization screen, and you can say, at any frame, you can go and look, let's look at this frame. What about this scene? What about that scene? You can go in, press the magic show frame button, and then you can actually look at the frame and do your comparison. And you can also look at this and say, there's really tiny differences throughout. Very different graph than what we saw with our CBR versus VBR comparison. CBR versus VBR, it was very, very close, but then it jumped up. We're not seeing that here. We're seeing very, very minor differences between the two files that no viewer would ever notice. And this is between the 5 or 6.5 megabits per second stream. Here's a case where we're starting to see some differences. Then you can go in, you can play the videos at full speed, see if you notice a difference. You can look at the frames, see if you notice a difference there. Bottom line is, if you have the numbers and you have the tool, you can really isolate how much differences there are in your, because these are the ones you care about, right? These are the ones that cost the money. You don't really care about the 300 kilobits per second stream, because that's really not a lot of bandwidth to spend. But up here is where you really get your significant cost savings. And then this is, we talked a few times about different video streams looking differently on different devices. This is an example where I ran one particular video file using the SQM quality, and we see that this file on the Sony X9, again, this is a 4K TV in expert mode, so the person's staring at the differences very close in. Down here, this file is in the good range. Up here on an iPhone, it's still in the excellent range. So you really, what I like about this tool is it really gives you a good appreciation for the differences in the viewing platform. And then, again, how low can you go? Here's the same files we talked about a few minutes ago. This is the SQM score, so higher is better. These are the high data rates. These are the low data rates down here. When do we drop below a score of 80? It's going to vary by movie or clip. Here we see Zoolander drop down below 80 in the 3500 to, and this is 3500 for 30 frames per second, 2800 for 24 frames per second. So I can compare all those files similarly on this chart. So if you're, basically you should be able to have a max rate of between 4 and 4500 and not see any visual loss of quality. A lot of people are really just encoding their videos at too high a data rate because they're afraid to have any degradation in the video. And then here's, I'm really into, what Netflix pulled together was called per title optimization. So per title is very, if you're Netflix, you can do it because you got tremendous computing power. Most people don't have that level of computing power, but what you can do in some instances is per category encoding. So you can have different encoding ladders for different categories of videos. And this is an example of the differences between real world and animated videos. So over here, and these are VQM, lower scores are lower scores are better. We got a 1.16 value For the real-world video, it's 7.5 or 6 megabits per second for a 24 frame per second video. We could get that same value at between 3,500 and 2,800 for animation down here. Depending on the clips you're working with, you might be able to cut your animated data rates by as much as 50% at the exact same quality level. And then it gets even more significant if you're looking at screen cams, or this is screen cam in PowerPoint, where at data rates in the very low range, like 2 megabits per second or 2,500 kilobits per second, you can get a 98.82 rating, which you can't get anywhere with a tutorial video or a real-world video. So, if you're encoding very disparate types of videos, if you're a training company, you've got talking head videos, you've got hybrid videos, you've got total screen cams, you really can benefit from encoding ladder. And when I say really benefit, I mean really benefit. I mean, I told this story once or twice. I apologize for telling it again if you've heard it, but I did recommendations for a consulting client for 720p at 200 kilobits per second for some of their screen cam videos. And they sent it to a cloud encoding vendor, and they didn't try and run the test, but they said, you can't do this. This is crazy. You'll never, this is going to look awful. And that's the common thinking. The common thinking is, well, 720p has got to be 1,500 to 2 megabits a second. And the bottom line is, depending on the content, it really doesn't need to be. And then the big thing about these tests is you really need a fast computer to run them. So I've got an HP Z840. If you're really going to throw this type of analysis, then you see the comparisons here from a time perspective. This is the Z840 with SSD drives. This is the Z800 with just regular fixed drives. And we see that we're decreasing the processing time by 85% to convert to YUV, to 49% with to run the Moscow University tests. So, and then real quickly, here's the Moscow University tool, maybe. That's interesting. OK, it's showing up on my monitor. Why is it not showing up on? Pardon? Oh, sorry. I didn't know that's what you guys were doing. OK, so here's the Moscow University tool. So this is comparing a 1,600 kilobit per second file and a 1,100 kilobit per second file, both at 1080p. And if I wanted to, I can move this to any frame I want. And then if I want to look at the frame, and then if I want to toggle between, this is the original, this is the first encoded, that's the second encoded. So again, if you're comparing two files or two, VBR, CBR, different keyframe settings, this is just an amazingly useful and usable tool. Pardon? Yeah. The question was, does it have any command line? And I'm laughing because you couldn't use it without. I mean, the encoding ladder analysis we saw probably took, it took maybe 20 minutes to set up, but it probably took 8 or 9 hours to run. And if you throw the encoding side in, for HEVC, it probably took 24 hours to run. So yeah, these tools are very, very automatable and pretty easy to use once you once you use them a couple times. Okay, we've got time for questions.
So obviously the objective quality metrics are highly dependent on the test content. So how do you go about picking good test content?
Great question. So the question was, how do you go about choosing test content? Typically, I think it's easier with some types of content than with others. So if you've got training, screen cam based versus PowerPoint with video, think that's pretty simple because all those are going to be pretty homogeneous. If you're looking at different types of, and if you're looking at a TV show, the Today Show or something that's going to be pretty regular, then I think you need to look at it on a show-by-show basis. If you're encoding movies, then I think you need to, I think you do need to do some work on the animation and on the, collecting groups of animated files and seeing if there's a way to come up with a new ladder for them. But I think what we're going to end up seeing in the next 6 to 24 months is per title encoding supplied by the encoding vendor. So one of the tools I just worked with is a tool called Cambria encoder from companies kind of spacing out. It's a new company that came from a much bigger company a few years ago. But what they do, it's kind of interesting. What they do is they do a pass with what's called constant rate factor encoding. So CRF is a feature of X.264, and it kind of CRF encodes the file to a certain quality level. So if you encode an animated file with CRF, you'll get maybe a data rate of 2 megabits per second. If you encode, Mission Impossible with CRF, the same value, you get a file that's like 8 megabits a second. So they do a quick run at CRF, they gauge the complexity of the file, and then they can adjust the encoding ladder up and down based upon that complexity. So I think you're going to see something like that in all the major encoding tools going forward. And the point I should make is that the encoding ladder is just one piece of that. You still have a lot of decisions to make on the configuration side, how to configure each stream, and then we haven't really considered the playback side, which I think is pretty important as well.
For the device-based quality ratings, is that just based on screen size, or is it also decoder?
They say it's based upon some assumptions about viewing distance, some assumptions about screen size, some assumptions about, I think those are the two main ones. So they expect you to watch the 4K TV from 8 feet. They expect you to watch the iPhone or the tablet from a much closer viewing distance. I don't think so, but that's a good question. But I think the answer is no.
You mentioned dropping 180p for one of your resolutions. Are you pretty much saying instead of doing 180p as your lowest, start at 27p?
Yes. So the question is, should you start dropping lower quality, lower resolution streams? I think so. Again, that's also a little bit content dependent. So you can get a pretty good looking 270p or 180p stream if it's a real world content. If you have anything with sharp edges like screen cams or PowerPoint, you run a separate test like this on that and you'll get very different results. That's why you to drop anything below. Sometimes the 720p content I was working at look better at 720p 200 kilobits per second than it did at 360p 200 kilobits per second because, again, the aliasing artifacts that were created when you scaled up. You don't notice those in a talking head video, but you do in any kind of video with sharp edges.
Do you have any other recommendations for how to automate these?
Yeah, I mean, batch encoding and then batch processing. So you really, I mean, I'm old enough to know what a batch file is, from way back before Windows. But I probably hadn't used them since then, and man, I'm really good at them now. So, which is kind of cool because I impressed my 16-year-old daughter. She's learning how to create a batch file in school, and I said, "You want to see a batch file?" And then you show her, there's like 10 streams running at the same time. It's pretty, but yeah, they're all batchable. The only thing you end up doing, which is kind of monkey work, is you got to copy and paste the results from the CSV file into the spreadsheet. But sometimes I get my daughter to do that and just pay her $10 an hour. But other than that, it's you can definitely do it and walk away. Yes, thank you. It's the Capella Cambria system, and it's a feature it's not it's something it's out there, it's working. I think we're going to have to tweak it a little bit. It's kind of a cool thing because you can tweak a bunch of it. You can tweak. So say you never want to have worse quality than your encoding ladder, but you do want to have better quality. You can tweak it and say, if it's above this certain level, increase the top levels or increase all levels. But if it's below a certain level, don't do anything. You can say, If it's above a certain level, increase it by 50%, but if it's below a certain level, you only decrease it by 10%. So do no harm, that kind of thing. So it's and then you can dictate how much of a file they look at. Do they look at any, if they do it based on the top 5 seconds, then even if there's a 5-second sequence that's high motion, it's going to boost the data rate in all cases. If they do it based on 60 seconds, you're going to get a different result. So they allow you to tweak it a lot. It's a pretty cool tool. But again, it's really new, so I don't know what the best parameters are for that. Any what? So the question is, any cloud service that does this? Not that I'm aware. I mean, because a lot of the time, you end up producing pretty huge YUV files. So in order to show you this on my computer, I had to convert the files to YUV. So YUV is a very, very, which doesn't mean you couldn't do that in the cloud. So you're right. I'm not aware of any service in the cloud that does this. Anybody else?
For high motion estimation content, such as like sports or gaming,
Yes.
is there a tuning preset that you would recommend when it comes to tuning of files that you
Any preset for high motion videos? It's so hard. I mean, I really think you need to. It's going to be different for soccer, football, baseball, basketball. I just think you need to run some tests and come up with some. The numbers really kind of jump out at you once you do the work. We should stop there, right? The numbers really jump out at you after you do the work. Any other questions? Okay, thank you very much.